these type of questions, we're just going to have a look at an example. Okay, so let's say, right, your friend or whatever approaches you for an investment, okay, and they ask you to give them 30 grand, okay, 30,000 euro, all right, for an investment in their business, and that's now, okay, which is 2020. Okay, so you give your friend 30 grand, all right, so that they can invest in their business, all right, and the idea then is, right, that they obviously have to pay you back. So we did an example like this in class, but in 1 year from now, okay, obviously it'll be 2021, okay, your friend says that they will give you back 10,000 euro, okay, and then in 2 years from now, so in 2022, all right, 2 years from now, your friend says they are going to give you another 10 grand back, okay, and then in 3 years from now, 2023, all right, your friend says that they are going to give you another 10 grand back, okay, and then that's the deal, all right, and it looks like it's a good deal because you're giving your friend 30 grand, okay, and then they give you 10 grand, 10 grand, and 10 grand over the course of 3 years, and that obviously adds up to 30 grand, all right, so it looks like you're getting your money back. All right, but as we discussed in class, you're not at all. All right, because as time goes on, the economy will grow. Okay, and remember, money has a time value. All right, so this 10 grand here is not worth the same as 10 grand now. This 10 grand is not worth the same as 10 grand now, and this 10 grand here is not worth the same as this 10 grand. It's not worth the same as this 10 grand, and it's certainly not worth the same as 10 grand here. Okay. So this is the questions now where we have to work backwards, okay? So to see if this is a fair deal or not, right, we need to get this 10 grand and we need to bring it back to today's money, all right, when you gave your friend 30 grand. We also need to get this 10 grand and bring it back, okay, to today's money, and we need to bring back this 10 grand, which was 3 years away, and we need to bring that back, okay, to today's money, all right, and then see how do these compare to the 30 grand, okay, so that's what we need to do here. So just the idea is that as time goes on, all right, money will get less valuable, so this 10 grand here is not the same as this 10 grand and so on. So to figure these numbers out here, once again, like everything in this chapter, we need to use this formula, okay. Oh yeah, by the way, we're going to assume that for now and all the way up to 2023, okay, the economy is growing at a rate of 3%. So it's kind of like the AER is 3%. Okay, so we need to use this formula now, all right? But if you think about it, all right, these are the future values because they're in the future. So we know F and we're trying to find the present values. So I'm just going to manipulate this formula a little bit. Okay, I'm going to get P on its own, and obviously then it'll be F all over 1 plus I to the power of T. Okay, so we were using this formula, okay, in the savings questions in the last video. I'm not using that formula anymore now. I'm using this one. Okay, so let's bring back these 10 grands now, all right, to present values. Okay, so the first one, okay, so if I'm going to fill in this formula, so for year 1, okay, the first one, if I was to fill in this formula here, the future value was 10,000 all over 1.03, because it's 1 plus the rate is 3%, is 0.03, so that's going to be 1.03, and then to the power of T, that's going to be 1 year away. Okay, and that gives me P is equal to, so that gives me, if I type that into the calculator, that gives me 9,708 and 74 cents. Okay, so that means that your friend giving you 10 grand in a year's time is actually the same as your friend giving you 9,708 euro and 74 cents. Okay, so let's do year 2 now. Okay, so once again, if I fill in this formula here for year 2, the future value is 10,000. Your friend is giving you 10,000, but it's going to be 1.03, but now it's going to be to the power of 2 because it's 2 years away. Okay, so once again, if you type that into your calculator, you're going to get €9,425 and 96 cents. So your friend giving you 10 grand in 2 years' time is really only the same as your friend giving you €9,425 and 96 cents. Okay, and then you would do the same for year 3. Okay, you would type that into the calculator, but it would be to the power of 3, so I just won't do that. But that's coming to €9,151 and 42 cents. Okay, so your friend giving you 10 grand in 3 years' time, he's actually only giving you the equivalent of this much now. Okay, so if we go here now, if I add up these 3 numbers now, okay, if I add all those up there, it actually turns out that your friend is just giving you €28,286. Okay, in today's money. So you were giving him 30 grand. Your friend is giving you back 30 grand. Like 10 grand plus 10 grand plus 10 grand does equal 30 grand. Okay, but in today's money, if we calculate for present values, this is how much your friend is actually giving you. Okay, so this is not a good deal for you, all right, because your friend is not giving you back the same. Okay, so this example is very important for you for 2 things, all right, because now we're going to start using this formula, all right, and it's also important because you need to know that as time moves on, as time goes this way, all right, the value of money is going to be worth less and less. Okay, so here's the first question now that we'll do. And this is a mortgage question, okay? And you can see here I have the heading lump sum now and payment in the future questions, okay? So that's what these type of questions are called. But we'll talk more about that in a minute. So if we just have a look at this question here. So Mary and Shane are taking out a mortgage for €460,000 at an APR of 4.5%. Okay, now APR is the exact same as AER. Okay, it's just when you're borrowing money, it's called APR. How much will the monthly payments be? Okay, so here we have to stop. All right, because this 4.5% is once again annual, okay, per year, and Mary and Shane obviously want to pay back their mortgage monthly. Okay, so the first thing that you'd have to do is change 4.5%. All right, and you'd have to change that to what the rate would be. Okay, and we've done that in the last video. Okay, so I'm not going to do that. Okay, so the answer there, if you want to change 4.5%, all right, the monthly rate I is going to be 0.003674809. Okay, so that's what the rate is. So if you want to see how to do this, okay, just look back on the previous video. Okay, so let's get into this question now. So Mary and Shane, they want to pay back their mortgage in 30 years. All right, how much will they have to pay back per month? The first payment is made 1 month after the loan is drawn down. Okay, all right, so let's have a look at it. So again, like all of these questions, what I'm going to do first is I'm going to draw a diagram about what it's going to look like. And again, this diagram, you don't need to draw this in the Leaving Cert if you don't want to, but I will always draw these types of diagrams. So the bank have just given Shane and Mary 460,000 to buy their house. All right, so the bank have just given them 460,000 euro. So this is the same as you giving your friend the 30,000 euro in the last question. Okay, so what Mary and Shane need to do now is they need to pay it back. So the bank have given them this now, okay? And Mary and Shane need to pay it back every month, all right? And if we look at the question here, the first payment is made 1 month after the loan is drawn down. So they're given their money and they can buy their house, okay? And now in month 1, all right, they need to pay back some amount. And that's what we're looking for. We don't know how much they're paying back, but they need to pay back some amount, okay? In month 2, okay, they need to pay back another amount, all right? Month 3, they need to pay back another amount, and then obviously we're going to skip, okay? We're going to skip loads of months because they're going to be paying back their mortgage for 30 years, all right? So that is 360 months. All right. So in 360 months, in 30 years' time, they're going to also pay back some amount. And obviously, I've skipped here, all right, nearly 30 years worth here, all right. Okay, so, but just like in the last question, all right, all these amounts that they're paying back, they are all occurring in the future, okay, and the economy is growing, all right. So all these amounts are not worth the same as as when this money was given to them. So just like in the last question, all right, we're going to have to get this amount here, which was 1 month away, all right, and convert it back to today's money. We'll have to get this amount, convert it back to today's money, get this amount, convert it back to today's money, all the amounts here, and even the very last amount, which is in 30 years' time, that's going to have to be converted. Okay, and then if the bank are going to get their money back, which they obviously want to get their money back, all these amounts here, okay, when we add all of these together here, we obviously need to get 460,000 euro because the bank obviously want to get their money back. Okay, so when we add up all of these here, we need to get 460,000. So that's basically the diagram. Okay, if you want to rewind, you'll see it is pretty much the exact same diagram as the simpler example we did when your friend was borrowing 30,000 euro from you. Okay, except this is a lot longer. It's over 30 years. All right, but every amount that Mary and Shane pay back, okay, it needs to be brought back to today's money because this is when the bank gave you the money. All right, and all these amounts here, they obviously all need to add up to 460,000 because the bank want to get back what they gave you. Okay, so now we're going to use this diagram here to actually do the maths, okay, for this question. And then obviously this part that I'm going to do here now, this would be the part that you would need to show in an exam. Okay, so we'll do month 1 first, okay? So the amount that they pay back for month 1, okay, we need to bring it back to present values. Okay, so as I said in the last question, all right, we're not using this formula anymore. Okay, we're actually using this formula. Okay, so we're not using this one, we are using this one here. Okay, that's supposed to be an F. All right, and the reason why we're using that is because we know the future values. These are all the future values, okay, and we need to bring them back to get the present values here. Okay, so if we were to do, okay, month 1, all right, so let's do month 1 first. So in month 1, as we can see here, right, Mary and Shane, they are going to pay back that amount of money, all right, and then to bring it back to today's money, following this formula, it will be all over, okay, all over 1 plus I, but we know the rate is this big long number here, so it would be 1.003674809, okay, and they are paying that back 1 month away from when the money is given to them, so that would just be to the power of 1. Okay, so that is that one there sorted. All right, so we have adjusted it back to today's money, and that is what it would look like there. Okay, then in 2 months' time, okay, they're going to pay back some amount. All right, all over 1 plus I, so once again it's going to be 1.003674809, but that's 2 months away. Okay, so that is that amount there, so brought back to today's money. And then now we're going to do month 3. Okay, so we have month 3. Once again, Mary and Shane are going to pay back some amount. All right, and filling in the formula 1.003674809, but that's 3 months away. Okay, so that is this one here, brought back to today's money. And now obviously I'm not going to write out all 30 years. All right, we're going to go to the last payment. Okay, so we're going to skip loads here, and now we have month 360, which is 30 years away. Mary and Shane are once again going to pay back some amount. All right, it'll be 1.003674809, okay, and that is going to be 360 months away. All right, so that is all. So now we have all these numbers here, all the present values, okay? And as I said, if the bank want to get their money back, if we add all of these up, they need to equal 460,000. So if I add all of these up, okay, if we add all of these payments up here, okay, they need to equal 460,000. So I'll just squeeze that in here. All of these payments here, they need to equal 460,000 euro. Okay, so they all need to equal that. Okay, so now the financial maths bit is over. All right, and now it's just a matter of doing the maths and using geometric series to do it. So as I said before, all right, once again, if you look here, A is common. So I can take out A. Now, if I take out A, just be careful. If I take out A, I'm left with 1 over 1.003674809. All right, because I still need to have something on top. I took out the A, but there still needs to be that down. Right, plus 1 all over 1.003674809. That would be squared. Okay, and then I might just skip the third one there, plus blah 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 blah, plus 1 all over, and then I'll write down the last one, which is 1.003674809 to the power of 360. Okay, so I just took out A there. Okay, now I can look at this here. So again, once again, this is a geometric series. All right, and I'm able to add all these up together very quickly, even though there is 30 years of them here. There's 360 months. So once again, okay, to add all these up, always write down a formula before you use a formula. So that would be the formula there, okay? And if I was to fill in that formula now, okay, I would be finding S360, okay, because there's 360 of them I want to add up. A is always the first term, okay, so A is going to be this term here, 1 over 1.003674809. Okay, I need to multiply that now by 1 minus R. So that's 1 minus, now if we look at R is going to be the same because R is the common ratio. All right, so we can see that R is also 1 over 1.003674809. All right, and then all of R, has to be to the power of 360. Okay, like that. So I'm just following the formula. All over 1 minus R, which once again is 1 over 1.003674809. Okay, so that gives us that. All right, so you can just load all of that into the calculator. Okay, so by loading all of that into the calculator, I get A. All right, and then what I got when I put that into the calculator, I got 199.467. Okay, now, but let's remember, all of these values here added together, which is all of these values, the present values, if the bank are going to get their money back, they all need to add up to give you 460,000, which is what the bank gave Mary and Shane. So that's why I wrote it here. All of these values here need to add up to 460,000. So therefore, all of that then needs to equal 460,000. So then very simple then to get A on its own, it's obviously going to be 460,000 divided by 199.467. So my final amount is going to be €2,306.15. Okay, so that is how much Mary and Shane would need to pay back, okay, every month to pay back their mortgage. Okay, so this amount here would need to be €2,306.15. All right, and all these amounts would be the same. When they are adjusted then back to present values, all their present values would add up to 460,000. Okay, so that question there, all right, this one here with Mary and Shane is considered a mortgage question. Okay, now as you can see here, all right, it says do this question using geometric sequences first. Okay, so we did that. We did it that way. Then use the amortization formula. So you can also do a mortgage question using the amortization formula, which I'll do next. Okay, so this is the amortization formula. Okay, so you will find this in the log tables, And also remember that they can ask you to derive this, or they can ask you to prove where this came from. Okay, so that is just something that you need to learn it off by heart. It's in the book, in the financial maths chapter, but you do need to prove or derive this formula here. Okay, but to use it for this question with Mary and Shane, okay, so their monthly repayments, okay, will be as follows. You just fill in the formula. So the present value, or the principal that the bank are giving them, is 460,000 for their mortgage, okay, and then we'll fill in this here. So I is the monthly rate, so that was 0.003674809, multiplied by 1 plus the rate which the bank are giving them, which is going to be 0.003674809, and that's to the power of time, which is going to be 360 months, all over 1 plus, once again, the rate 0.003674809 to the power of the time, which is 30 years or 360 months, minus 1. Okay, so I just filled in the formula exactly as it is there. Okay, then you go to the calculator, all right, and you get €2,306.15, which is the exact same answer that I got when we did it the other way. Okay, so the two ways of doing it, this is just using the amortization formula, and the other way is using a geometric series. Okay, and they could ask you either way in the exam.